Okay, welcome back friends. In the previous lecture we studied about the quadratic equation and we have seen how to form a quadratic equation, and we have also seen one of the methods of solving a quadratic equation. Right now in this lecture we are going to continue with the second method of how to solve or solution of a quadratic equation. Right, the first method that we discussed earlier was the factorization method. Now in today's lecture we are going to see the solution of a quadratic equation by completing a square method. Right, by completing a square method. So the second method, that is completing a square method. This is the method of solution of a quadratic equation. Now let us see what the method actually says. By completing a square method, that means completing a square means to make the quadratic equation a perfect square. Right, to make the quadratic equation a perfect square, and then we are going to factorize. Like for example, if I am having an equation that is x square plus x minus 306 equal to 0. For example, I am having an equation here that is x square plus x minus 306. Now if I want to factorize this, then for what I am going to do, I am going to split the middle terms. But as we seen in factorization method, we are going to split the middle terms. But here by completing a square method, that means first of all we are going to set these last term here. Right, what we are going to do, we are going to set this last term here. This is the last term. We are going to set this, according to that what we get it as a perfect square. So for that, first of all, what is the first step? Check whether the first term is a perfect square or not. Check whether the first term is a perfect square or not. How to check whether it is a perfect square or not? See, the perfect squares available to us in numbers are 1, 4, 9, 16, 25, 36, 49 and so on. These are all the perfect squares because the square root of them is a perfect integer. Now check here that the first term here is x square. The coefficient associated with x square is 1. So we can say that yes, this is a perfect square. See which terms are not perfect squares, that is 2x square, 3x square, 5x square, 6x square, 7x square. These are all not the perfect squares. That means the square root of 2x square is root 2x. Right, the square root of 2x square is root 2x, and that is not a perfect square because root 2 becomes a irrational number. So we cannot say that this is a perfect square. These are all non-perfect squares. So first of all we shall check whether the first term is a perfect square or not. Now if not, that means if it is not a perfect square, then multiply the equation by the coefficient of x square present. Right, if not, that means if it is not a perfect square, then we are going to multiply whole equation by the coefficient of x square present there. That means when and when you are having an equation, let us say randomly there is an equation 2x square plus 3x plus 4, and if I want to solve this equation by completing a perfect square or completing a square method, then what I am going to do, first of all I am going to check whether the first term is a perfect square or not. See here, this 2x square is not a perfect square. That means we need to make that as a perfect square. So what I am going to do, I am going to multiply the whole equation by 2. That will give me 4x square plus 6x plus 8. Only check the first term right now. Only check the first term right now. So the first term here is 4x square, and now that is a perfect square because the perfect square of 4x square or square root of 4x square is 2x. So 4x square can be written as 2x whole square. Right friends, so this is how you can check whether the first term is a perfect square or not. So first of all, check whether the first term is a perfect square. If not, multiply the equation by the coefficient of x square present. Then second step, the second step is you need to find out the last term. Now you need to find out the last term using the formula middle term square upon 4 into first term. Right, you need to find out the last term by using the formula last term equals to middle term square upon 4 into first term, where LT is last term, MT is middle term, and FT is first term. So last term equals to middle term square upon 4 into first term. You will find out the last term here. Note that this last term and this last term will be different. Only and only there are some cases where the last term that you find out using this formula and the last term available here will be same, and those conditions or those special cases are the equations itself is a perfect square, the whole equation itself is a perfect square. Right, we will see such examples later on. Now, so the last term equals to middle term square upon 4 into first term, and the third step is add and subtract the last term obtained in step 2 in the given equation and factorize. Right, add and subtract the last term obtained in the step 2. That means the last term that we get here in step 2 will be added and subtracted simultaneously at the same time. At the same time they are going to add it and subtract it. So add and subtract the last term obtained in step 2 in the given equation and then factorize. So this is basically how you can use this completing a square method. These are the basic steps. Note that friends, these steps are not given in the textbook nor anywhere in any other reference books, right? So please note it down, and the method that we are going to discuss here is also not given in the textbook. The method that is given in the textbook is somewhat of a different kind. So I am going by the easier method so that the students and the people that can understand it quite an easy way. Now let us see for the given example. Here the given example is x square plus x minus 306 equals to 0, right? So the first step, check whether the first term is a perfect square or not. Is x square a perfect square? Yes, obviously it is a perfect square. So we are not going to multiply, because if not a perfect square then and then we are going to multiply here, right? Now if we don't want to multiply, then we are going to move on to the second step, that is last term equals to middle term square upon 4 into first term, right? So middle term, that is x, first term, that is x square, that is x square upon 4 into x square, right? That again becomes x upon 4x square and x square is cancelled, and that becomes 1 upon 4, right? So we got the last term here, that is 1 upon 4. So we have completed our second step. Moving to the third step, that add and subtract the last term that we got here in step 2 to the given equation. Therefore x square plus x plus 1 upon 4, we have added this and we have subtracted. Note that friends, you will write the equation like this so that you can easily come up with a perfect square here and these term will be remaining as it is. See, the second term here are only the constants, and here they are the variables, right? So the variables will be left out in the first part and the constants will be left out in the second part. Okay, so this will make the solution easier for you to understand. So let us try to solve it now further. That we shall get this, that is x square plus x plus 1 upon 4 minus, this will be 1 2 2 4, 4 into 6 24, 4 into 3 12, 1 2 2 4 minus 1 upon 4. Yes or no? Right? So friends, this will become, this minus is associated this with 1 2 2 4 is equals to 0. Now this becomes a perfect square. You can check it out. How? Let us see. That is x square plus 2 into x into 1 by 2 plus 1 by 2 whole square. Yes or no? X, that is x whole square, x, that is 2 into x into 1 by 2. This 2 and 2 can be cancelled, so the remaining thing, that will be x, and 1 by 4 can be written as 1 upon 2 whole square, right? So that is the first part, minus 1225 upon 4 equal to 0. Minus 1224 minus 1, that is minus 1225 upon 4. Hence this becomes x plus 1 by 2 whole square minus square root of 1225, 35. Yes or no? It might be 35, you can check it out, or it will be 35, that is 35 upon 2 whole square is equal to 0, right? So that is a whole square minus b whole square. Assume this whole term as a and this whole term as b. So you might remember the formula, that is a square minus b square, that is a minus b into a plus b. You need to remember this identity that we have already discussed in standard 9, right? So you will take x plus 1 by 2 as a and 35 by 2 as b. Therefore x plus 1 by 2 minus 35 by 2 into x plus 1 by 2 plus 35 by 2 is equal to 0, right? That is a minus b, a plus b. So that will become x minus 34 by 2 into x plus 36 by 2. 1 by 2 minus 35 by 2, that is 1 minus 35 minus 34 by 2, and x plus 36 by 2, that will give me again is equals to 0. I forgot to write here, that is x minus 17 into x plus 18 is equal to 0, and hence x is equals to 17 and minus 18. So the solution to the given equation, is 17 and minus 18, or the roots of the given equation are 17 and minus 18. So friends, it might be clear with you that how to solve this kind of sum by using completing a square method. Let us again quickly discuss this. The steps I think you might write down on a book there, and then you solve this sum so that you can easily come to know that how to solve them. Check whether the first term is a perfect square or not. So first term, that means the coefficient of x square, that is a must be a perfect square. If not, then multiply the equation by the coefficient of the x square present over there. That means if it is 2x square, then multiply the whole equation by 2. If it is 3x square, then multiply it by 3. But if it is a 4x square, then don't multiply, because it is already a perfect square, right? So that means you need to remember the perfect squares, as I said: 1, 4, 9, 16, 25, 36, 49, then 64, 81 and 100, right? You need to remember the perfect squares up to 10, so that it might be helpful for you to solve the example. So if not, multiply the equation by the coefficient of x square present. Step 2, find out the last term by using the formula last term equals to middle term square upon 4 into first term, right? Last term equals to middle term square or square of the middle term upon 4 into first term. And then the third step, add and subtract simultaneously. Simultaneously, that means at the same time, the last term obtained in step 2 in the given equation and then factorize, right? So we are going to add and subtract this last term obtained in step number 2, and you can check out the example that is shown here, right? So that is how we are going to solve it, by completing the square method. Is it clear, friends? Okay. Let us move further with some of the examples I am having of the same kind, and then we will see a special case where the completing a square method is limited, and then we shall move on to the last topic, that is the quadratic formula, right? See, friends, the examples that I gave you yesterday in homework, I think that you might have done those examples by the factorization method. One of the examples that we took right now was of the same kind, that is the first one of yesterday's, right? Now, you might have seen that those examples can also be solved by using the completing a square method, right? So, in today's homework, you are going to solve those examples that we solved in the first part, that is formation of quadratic equation by the quadratic formula. Now I am having another example here, that is x square plus 4x minus 5 is equal to 0. So note that, friends, here again, what is the first step? Yes, the first term must be a perfect square. Here the coefficient of x square is 1, and hence x square is already a perfect square. That means there is no need to multiply anything over here. Now what you are going to do? Calculate the last term. That means last term equals to middle term square upon 4 into first term, right? That means 4x whole square upon 4 into x square, right? So that will become again 4x whole square, that is 16x square upon 4x square. X square and x square is cancelled. 16 and 4 can be cancelled by 4 again. So that will give me the last term as 4, right? So we got the last term as 4. Now the next step is we shall add and subtract this last term we got here in the given equation. Therefore now x square plus 4x plus 4 minus 5 minus 4 equal to 0. See, I have added first. Note that you will always first add and then subtract. That means first I have added the last term that we got here in the second step, then writing down the given last term of the equation, and then subtracting the last term we got in step 2. That means first and second term of the equation plus last term that is in step 2 minus the last term in given equation, and again minus the last term in step 2, right? So that what will happen is this first, second and third term here will become a perfect square, and the last two terms are the constant terms present. Is it clear? So what will happen here will be, now in short, if I want to write it like how to write down in short rather than writing down all these steps, because these kind of questions are being asked only in 2 marks maximum at max. Then how to solve them in short? That means rather than writing down all these steps in detail, see, the perfect square here will be exactly as this. Write down a bracket and make a square of this. Now the terms inside the bracket is square root of the first term, that is x, square root of the last term, that is 2, and sign of the middle term. That middle term, the sign of the middle term, whether it is plus or minus. Here it is plus, so we shall write it down as plus, right? So that is equals to x plus 2 whole square. Is it clear? That is x square plus 4x plus 4, that is x plus 2 whole square. Or you can also write it like x whole square plus 2 into 2 into x plus 2 whole square minus 9 equal to 0. So then again this becomes x plus 2 whole square minus 3 square is equal to 0, right? So this 9 is written as 3 square. Again we shall use that formula here, that is a minus b into a plus b is equal to 0. Therefore we get x minus 1 into x plus 5 is equal to 0. Therefore x minus 1 equal to 0 or x plus 5 is equal to 0. Therefore we can say that x equal to 1 or minus 5, right? So the solution of the given equation is 1 comma minus 5, or the roots of the given equation are 1 and minus 5. Is it clear, friends? So this is how you can solve it by completing a square method, right? One more example I am having here is 2x square minus 5x plus 3 is equal to 0, right? Now you can clearly observe that as we discussed in step number 1, the first term must be a perfect square, but here the first term is not a perfect square. So what we are going to do is multiply the given equation by 2, right? Therefore we get it as 4x square minus 10x plus 6 equal to 0. Is it clear, friends? Now as and when the first term becomes the perfect square, now we are going to move on to the second step, that is finding the last term. Therefore last term equals to middle term square upon 4 into first term, that is minus 10x whole square upon 4 into 4x square, right? That is 100x square upon 16x square. X square and x square is cancelled, that is equals to 100 upon 16. You can cancel the fraction by 4 and that becomes 25 by 4, right? So we got the last term as 25 by 4. Don't worry if you get some fractions in the last term, right? Simply make sure that you are not making any mistake over there. If you are making any mistake over there, then that will cost you much, like you will not get the answer, or it will result when you fail to solve the sum and you will keep it as it is and you won't solve further, right? So we got the last term. Now what to do? Now we are going to add and subtract this last term that we got in step number 2 to the equation. To the equation, that means which equation? The first or the second one? So we are going to add and subtract to the second one. Now 4x square minus 10x plus 25 by 4 plus 6 minus 25 by 4 equal to 0, right? So again this will become a perfect square and this is the constant term, right? Therefore what we can write it as 2x whole square minus 2 into 2x into 5 by 2 plus 5 by 2 whole square. This 25 by 4 can be written as 5 by 2 plus 24 minus 25 by 4 is equal to 0, right? So this 4 into 6 is 24 minus 25 all divided by 4. I have taken the LCM over there. Therefore, that becomes 2x minus 5 by 2 whole square plus, sorry, not plus, this will become 24 minus 25, that is 1 by 4 is equal to 0, or minus 1 by 4 is equal to 0. Therefore, 2x minus 5 by 2 whole square minus 1 by 2 whole square is equal to 0. Therefore, again solving them, what will I get? 2x minus 5 by 2 minus 1 by 2 into 2x minus 5 by 2 plus 1 by 2 is equal to 0. That is the formula of a square minus b square, that is a minus b into a plus b, right? So that becomes 2x minus 6 by 2 into 2x minus 4 by 2 equal to 0. Therefore, 2x minus 3 into 2x minus 2 equal to 0. Hence you can say that 2x minus 3 is equals to 0 and 2x minus 2 is equal to 0. Hence finally x is equals to 3 by 2 and x is equals to 1. So the solution of the given equation x 2x square minus 5x plus 3 is equals to 0 is x equals to 3 by 2, right? So friends, what you are going to do again in today's work is you are going to solve the sums that we discussed in the previous lecture by using this completing a square methods. That means the questions that I have solved in the factorization method and in the formation of a quadratic equation, you will solve those same examples by the method of completing a square method. That means you can get more practice of the same kind of the sums, right? And the answers are already available to you in those solutions. That means you can also verify whether you are getting those same answers or not, right? So look out for the video lecture of part 1, get the questions from there and solve it by this method, that is completing a square method. So take a look over it and then we shall move on to the next sums. Right? Okay, let us move on to the next. That is 9x square minus 15x plus 6 is equal to 0, right? Again I am having an equation here, that is 9x square minus 15x plus 6 equal to 0. Now the first step, looking for the perfect square, whether first term is a perfect square or not. Yes, here the first term is already a perfect square because 9 is a perfect square, that means square root of 9 is 3, so that is a perfect square. Now what we are going to do is we are going to find out the last term, that is middle term square upon 4 into first term, that is equals to minus 15x upon 4 into 9x square, right? That is 225 x square upon 4 into 9x square. So you can cancel out this x square and x square, right? You can cancel out this 225 by 9, that is 9 into 2 18 and that is 5. So again we got the last term here, as 25 by 4, right? So we got the last term as 25 upon 4. What we are going to do next is we are going to simply add and subtract. Therefore 9x square minus 15x plus 25 by 4 plus 6 minus 25 by 4 equal to 0. Therefore this 9x square can be written as 3x whole square, right? This 9x square can be written as 3x whole square minus 2 into 3x into 5 by 2 plus 5 by 2 whole square. Friends, note that what is this? That is the formula of a square a minus b whole square, that is a square minus 2ab plus b square. So what I have done is I have simply split this minus 15x such that it is represented as a product of the first and last terms, right? So the square root of last term is 5 by 2, square root of first term is 3x, and 2 as it is. You can check out this 2 and 2 can be cancelled, and 3 into 5 15 into x, that is 15x, right? So I'm sure that you might have got this point here. Plus 24 minus 25 by 4 is equal to 0, right? So here we get this thing as 3x minus 5 by 2 whole square minus 1 by 4 is equal to 0. Therefore 3x minus 5 by 2 whole square minus 1 by 2 whole square is equal to 0. Hence we apply the formula of a square minus b square, that is a minus b into a plus b, that is a minus b and a plus b. So solving it, we get 3x minus 6 by 2 into 3x minus 4 by 2 is equal to 0. Minus 6 by 2, that is minus 3, and this is minus 2, so that is 3x minus 3 into 3x minus 2 is equal to 0. Therefore we get 3x minus 3 is equal to 0, or 3x minus 2 is equal to 0. Hence we get x equals to 1 and 2 by 3. So the solution of the given equation is 1 comma 2 by 3, or the roots of the given equation are 1 and 2 by 3. Is it clear? Right? Okay, let us solve one more. I am having an equation that is 5x square minus 6x minus 2 is equal to 0. Again we shall check for the first term. Here, is the first term a perfect square? No, the first term is not a perfect square. So multiply the given equation by 5. Therefore we get 25x square minus 6 into 5 30x minus 5 into 2 10 is equal to 0, right? Therefore now we shall find out the last term, that is middle term square upon 4 into first term, that is equals to minus 300x whole square upon 4 into 25x square, right? That is 30x, not 300x, friends. I have made a mistake here, is 30x whole square, right? So 30 square of 30, that is 900x square upon 4 into 25, that is 100x square. X square, two zeros can be cancelled, and hence we get the last term as 9, right? Now what? Add and subtract the last term that we got here in the given equation. In the given equation, that means now we shall add it in this equation that we have got after multiplying 5. Therefore 25x square minus 30x plus 9 minus 10 minus 9 is equal to 0, right? First of all we have added 9, then we have subtracted 9. So what we will get here is 5x whole square minus 2 into 5x into 3 plus 3 whole square minus 19 is equal to 0. Is it clear? Therefore solving this, we shall get 5x minus 3 whole square minus root 19 whole square is equal to 0. Is it clear? See friends, this 19 here, that is an odd number, and odd number, that means you can say that again 19 is an odd number, but it is not again a perfect square. So to write down in the form of a perfect square, we shall use the concept of the first chapter of standard 9, that 3 or any number can be written as the square of its irrational number. Its irrational number, that means the same number, right? That means 19 can be written as root 19 whole square. Therefore we get, using the formula of a square minus b square, that is a minus b into a plus b, that is 5x minus 3 minus root 19 into 5x minus 3 plus root 19 equal to 0. Hence 5x minus 3 minus root 19 equal to 0, or 5x minus 3 plus root 19 equal to 0. Therefore you can say that 5x is equals to 3 plus root 19, or 5x is equals to 3 minus root 19. This both the terms will be taken on the other side, note, right? Therefore x equals to 3 plus root 19 by 5, or 3 minus root 19 by 5. So finally we can say that x is equals to 3 plus or minus root 19 by 5, right? Combining both the roots, we can get these values, that is 3 plus or minus root 19 by 5. Hence the roots of the given equation are 3 plus or minus root 19 by 5. Is it clear everyone? So make sure that you write down the steps in the perfect manner so as to get the perfect answer. Is it clear everyone friends? Right? Okay, note down, then we are going to move on to the next sums. Okay. 2x square plus x minus 528 equal to 0. I've got this question here. So first of all, what we are going to do? We are going to multiply this equation by 2. That means multiply the given equation by 2. Therefore, we get 4x square plus 2x minus 1056 equal to 0. Right? 1056 equal to 0 because 528 into 2 is 1056. Now, what we shall do? Find out the last term. Last term, that is middle term square upon 4 into first term, that is 2x whole square upon 4 into 4x square, that is 4x square upon 4 into 4x square, and that is 1 upon 4. Is it clear? Therefore, what we shall do now? We shall add it, that is 4x square plus 2x plus 1 by 4 minus 1056 minus 1 by 4 equal to 0. Right? Now we shall multiply this 1056 into 4, and that gives me, what does this give me? 4224, that is 4, sorry, my mistake, not 4x, that is 2x whole square plus 2 into 2x into 1 by 2 plus 1 by 2 whole square minus 4224 minus 1 upon 4 equal to 0. Right? So that is 2x plus 1 by 2 whole square minus 4225 upon 4 equal to 0. Now can you see what is square root of 4225? 65. Right? Check out that square root of 4225 65, or square of 65 is 4225. Therefore 2x plus 1 by 2 minus 65 by 2 whole square is equal to 0. Therefore again applying the formula, that is 2x plus 1 by 2 minus 65 by 2 into 2x plus 1 by 2 plus 65 by 2 is equal to 0. Right? So that goes for the formula of a square minus b square, that is a minus b into a plus b. Therefore we get 2x minus 64 by 2 into 2x plus 66 by 2 equal to 0. Right? And hence we get 2x minus 32 into 2x plus 33 equal to 0. Therefore 2x minus 32 equal to 0, or 2x plus 33 equal to 0. Hence x equals to 16 or minus 33 by 2. So the solution of the given equation is 16 and minus 33 by 2, or the roots of the given equation are 16 and minus 33 by 2. Is it clear, friends? Right? Okay. Moving on to the example of the next kind, that is very important, as we have discussed that 4x square plus 4 root 3x plus 3 equals to 0. I said you that the special case of this kind of sum is where you get the last term that you find in second step exactly same as that is given in the question. The last term that you find out in step number 2 is exactly same as that we have in the question. Let us check it. So first step, is the first term a perfect square? Yes, the first term is a perfect square, so we are not going to do that. Moving on to the second step, that finding out the last term. Last term is equals to middle term square upon 4 into first term, that gives me 4 root 3x whole square upon 4 into 4x square. Right? So what is this equals to? That is 4 root 3, 16 into 3, 48x square upon 16x square. X square and x square is cancelled. 16 into 3, 48. So we got the last term here as 3, and note that we are already having the last term in the question as also 3. So what does this indicate? This indicates that if the last term we get in step 2 is same as that given in the question, then there is no need to add and subtract the last term of step 2, right? If the last term is same as that we get in step number 2 and that in the given question, if the last term we get in step 2 is same as that given in the question, then there is no need to add and subtract the last term of step 2. So now we are not going to add it. That means this given question is simply a perfect square. Therefore 4x square plus 4 root 3x plus 3 is equal to 0 is as it is, and that becomes 2x square plus 2 into 2x into root 3, right? That is 2 into 2x into root 3 plus root 3 whole square is equal to 0, right? And hence we get that as 2x plus root 3 whole square is equal to 0, and this means that is 2x plus root 3 into 2x plus root 3 equal to 0, and that gives me again x equals to minus root 3 by 2 and x equals to minus root 3 by 2, right? So friends, take a look over here. That is, if the last term that we get in step number 2 is exactly same as that we get exactly same as that given in the question, then there is no need to add and subtract the last term because it is already same. And if this happens, then the roots that we get is same, right? Both the roots are same. That means if the given question is a perfect square in itself, then the roots or the solution of the equation is same. That means both the roots are same. Is it clear, friends? So that is the special case that we were talking about. Is it clear? Okay. Then see friends, there are some more questions also that you can solve it by yourself. And now after solving this, completing the square method, we shall move on to the third method, that is the quadratic formula, right? So before discussing that quadratic formula, I want to guide you to the quadratic formula, that how this quadratic formula came into existence, right? This was the method that was last or laterly discussed, right? This was not the first discussed. The first discussed method was the factorization method that we have solved in the previous lecture. Today we discuss about the completing a square method. Now when the mathematicians came to an existence, that means they came across some questions, like those questions were neither solved by the factorization method, neither they can be solved by the completing a square method. Then what to do? They were a quadratic equation, right? Let me take for example, I am having an example here, that is 4x square plus 3x plus 5 equal to 0. Get me the factors of this. See, this 5 into 4 is 20, and 20 can be factorized in I think 4 or 5 different manners, 4 manners. 20 into 1 is 20, 2 into 10 is 20, 4 into 5 is 20, and 10 into 2 is also 20, right? So in those factors you cannot get the remainder as 2. Why? Because see, both the terms, middle term and last term, is having a sign plus. That means the factors that we get must be plus plus. according to the table that we discussed in the first lecture or the previous lecture, right? So this cannot be factorized, that means the first method is not applicable. Second method, completing a square method. So let us see that how we can not solve this by completing a square method. So first of all, what we shall do, check the first term, is it a perfect square? No, sorry, yes, right, it is a perfect square. So we shall find out the last term, that is middle term square upon 4 into first term, that is 3x whole square upon 4 into 4x square, that is 9x square upon 16x square, and that is 9 by 16. This x square and x square can be cancelled. Now we got the last term, adding to this, that gives me 4x square plus 3x plus 9 by 16 plus 5 minus 9 by 16 equal to 0, right? Therefore 2x whole square plus 2 into 2x into 3 by 4 plus 3 by 4 whole square. Till here I think you might have solved. Plus 16 into 5, that is 80 minus 9 by 16 equal to 0, right? Therefore we get 2x plus 3 by 4 whole square plus 71 by 16 equal to 0, right? Therefore 2x plus 3 by 4 whole square mine equals to minus 71 by 16. Yes or no? Minus 71 by 16. Then, or you can go by the method that we have discussed here, plus root 71 by 4 whole square equal to 0. Now what to do? Because we are not having the formula of a square, we are not having the formula of a square plus b square, is it? No, we don't have the formula of a square plus b square. So what to do now is that the limitation here is of the completing a square method. That means this method is now limited to this question. When we get a question such that the factors are not available to us, that means you cannot say that 2x plus 3 by 4 equals to minus square root of 71 by 4. Because if I cancel out the squares on both the sides, I shall get a plus or minus over here, and this plus or minus, this plus is applicable, but what about this minus? This is not possible. Right? Why this is not possible? Because when we remove the square roots, we get a negative sign over here, and the factors in this case is also not possible because a square plus b square is not applicable to any of the equations, right? So this is not possible. Hence, no real roots exist for this, right? No real roots exist for this. Then what to do? If I say that no real roots exist for this, then what to do? Right? For that, persons or mathematicians or the scientists, they might have invented the quadratic formula. The quadratic formula leads to the solution of this given equation. That means again, if I have this equation, that is 4x square plus 3x plus 5 equal to 0, I shall compare it with the standard form, that is ax square plus bx plus c is equal to 0. Standard form that gives me a equals to 4, b equals to 3 and c equals to 5, right? Now once we get this coefficients, that is a equals to 4, b equals to 3 and c equals to 5, we are going to lead to the formula, that is after getting these coefficients, we are going to look at the quadratic formula. Now, the quadratic formula is being x equals to minus b plus or minus root b square minus 4ac upon 2a, right? This is the formula. Let us derive this first, that how we get this formula. So again, for deriving this formula, we are going to look at the standard form. So the standard form of a quadratic equation is ax square plus bx plus c is equal to 0, right? Now again, we shall use the completing a square method for this. Why? Because we need to factorize this. Here we are not having the real numbers. The coefficients are not real numbers, that means they are not the numbers physically present over there, so we cannot use the factorization method. So rather than using the factorization method, we shall use the completing a square method. So what to do now is check whether the first term is a perfect square or not. See, the first term is not a perfect square, so what we shall do, rather than multiplying by a, we shall multiply the equation by 4a, given a is not equal to 0, right? Given a is not equal to 0, that means what this means, so we get the equation that is 4a square x square plus 4abx plus 4ac is equal to 0. Yes or no? We got this. Now what we shall do? We shall find out the last term, that is middle term square upon 4 into first term, that is 4abx whole square upon 4 into 4a square x square, that is equals to 16 a square b square x square upon 16 a square x square. 16 cancelled, a square cancelled, x square cancelled, so we got the last term as b square. Therefore 4 a square x square plus 4 abx plus b square plus 4ac minus b square is equal to 0. This will give me what? That is 2ax whole square plus 2 into 2ax into b plus b square. We shall take minus common from here, and that will give me b square minus 4ac is equal to 0, right? Therefore 2ax plus b whole square is equals to b square minus 4ac. What I have done, friends, is I have taken this term over here, whole term, the whole term b square minus 4ac, I have taken it on the other side. That means this minus will become plus over here, and therefore taking square roots on both these sides, that is 2ax plus b is equals to plus or minus root b square minus 4ac, right? What we have done, we have taken square root on both these sides. Therefore 2ax, this plus b will go over there, that will become minus b plus or minus root b square minus 4ac, and hence x is equals to minus b plus or minus root b square minus 4ac upon 2a. So this is the quadratic formula that I have written over here, that is minus b plus or minus root b square minus 4ac upon 2a, right? This question was asked in the recent examination, the previous board examination 2020. The question was asked is what are the roots of a quadratic equation ax square plus bx plus c if b square minus 4ac is greater than 0, right? Greater than 0, that means if the value exists, that means real and distinct roots will be available. We shall see the nature of roots here. Real and distinct roots will be available. That means the roots of the equation by the completing a square method of the general form, which leads us to the quadratic formula, is x equals to minus b plus or minus root b square minus 4ac upon 2a. So now in this method, what you are going to remember is, we are going to remember this formula, x equals to minus b plus or minus root b square minus 4ac upon 2a, and you can solve any of the sums that is available to you in the textbook by this method. Any sums, whether the sum that is given in the factorization method, whether the sums that is given in the completing a square method, and the sums that are given by the quadratic formula, right? You can solve any kind of sums by this formula. This is, I think, for me, the easiest method available to you for solving a quadratic equation. Rather than factorizing, sometimes there might be a question that the factors are too big for you to make, right? That but you will be like that. At that time, you can use this formula so as to get clear and easy factors, easy roots of the given quadratic equation. Let us solve some of the examples by this method so that you can come to know that how to solve this, right? See friends, this derivation is actually not very important, but it is good if you know that how to derive this quadratic formula, because sometimes there might be a question that find out the roots in 2 marks, or find out the roots of the general equation by the, or find out the roots of the given general equation by the completing a square method. That means you need to solve this quadratic formula, or you need to derive the quadratic formula, right? Now let me take for example okay, the third one, that is the quadratic formula. This was derived as a limitation of completing a square method, right? It was derived as a limitation of completing a square method, and the roots are x is equals to minus b plus or minus root b square minus 4ac upon 2a, right? So in this way you can find out the roots by this formula, that is minus b plus or minus root b square minus 4ac upon 2a. Let us take for example the example that we have solved in the previous one, that is 9x square minus 15x plus 6 equal to 0. Let us try to solve it. So first of all, what you are going to do, you are going to take out the coefficients here. A equals to 9, b equals to minus 15, and c equals to 6, right? Therefore, first of all, finding out b square minus 4ac, so that is b square minus 15 square minus 4 into 9 into 6, that is 15 square 2 5 minus 6 into 4 24 into 9 24 into 9. What is 24 into 9? 216. That is 216, right? So we got 2 to 5 minus 2 1 6, that is 4 plus 5 9, which is greater than 0. See, right now I am writing which is greater than 0. The next I am going to teach you about what the nature of roots decides, right, or what are the nature of the roots. So right now we are having b square minus 4ac is greater than 9 greater than 0. Therefore the roots of the equation are x equals to minus b plus or minus root b square minus 4ac upon 2a, that is minus of minus 15 plus or minus root 9 by 2 into 9, right, that is minus of minus 15. I made a mistake somewhere, okay, here itself, that is 15 plus or minus 3 upon 18. Therefore x equals to 15 plus 3 by 18 or 15 minus 3 by 18, right? So that is 18 upon 18 comma 12 upon 18. Therefore x equals to 1, and that is 2 by 3. You can check it out that the same example we have solved it in completing a square method. We got the solution there was x equals to 2 by 3. Here also we get the solution as x equals to 1 and 2 by 3, right? Now before solving some sums here, let us see what this decides or what the b square minus 4ac gives to you, right? Okay, let us solve sums, then we will decide, right? Because you have not come up with all the equations here right now. Okay, I am having one more equation here, that is 2x square plus x minus 528 equal to 0, right? Again check it that we are having this equation with the coefficients here a equals to 2, b equals to 1 and c equals to minus 528. Again I think this example also we have solved it in the previous one, so I am taking those examples that we have already solved so that you can come to know that the solutions that we get in both the method are same. I think this example you have already solved by the factorization method. We have solved this example in the completing a square method, and again I am solving it by the quadratic formula, so you come to know that the solutions will not differ in any of the method. Here a, b and c are this, therefore b square minus 4ac, that is b square 1 square minus 4 into 2 into 528, that is 1 minus minus, sorry, that is minus 528, minus minus plus, and this will be 4 2 2 4, that is 4 2 2 5, which is again greater than 0, right? Now b square minus 4ac is greater than 0, therefore the roots of the given equation are x equals to minus b plus or minus root b square minus 4ac upon 2a, that is minus 1 plus or minus root 4225 upon 2 into 2, right? Therefore x equals to minus 1 plus or minus root 65, sorry, root 4225, that is 65 upon 4. Therefore x equals to minus 1 plus 65 by 4 or minus 1 minus 65 by 4, right? X equals to 64 by 4 comma minus 66 by 4, and hence x is equals to 16 comma minus 33 by 2, right? So this is the solution. X equals to 16 and minus 33 by 2. Note that friends, again we got the same solution, that is 16 and minus 33 by 2. Right. Here we have solved two examples, and you might be thinking that why I am writing here this greater than 0, right? This greater than 0 shows you that the solution to this given equations in both the cases, that means given equations, that means equation number 1 and equation number 2 will have real and distinct roots, right? So that goes for the classification of the nature of the roots. The roots that we get here, that we have got here in both the cases, are real numbers, and they are again distinct. Distinct, that means both the numbers are different, both the roots are different. So this depends on the value of b square minus 4ac, and that is how I am going to write it down here, that what I am going to write down is now the nature of the roots. We got the roots here, that the roots are minus b plus or minus root b square minus 4ac upon 2a. Now goes for the nature of roots. See friends, this topic is given at last in the textbook, but we shall do it here with this quadratic formula so that we can come to know that what the roots will be, how the roots will be, and what is the nature of the roots when we solve further the examples related to this quadratic formula, right? So the nature of roots is, it is dependent on the value of the discriminant. You might have heard this word for the first time. Discriminant is also denoted by capital D, which is equal to b square minus 4ac, right? That means the discriminant of any equation can be obtained by b square minus 4ac. The value of b square minus 4ac will always be the discriminant of the given equation, right? So there are three possibilities when you get any number, that if that number is either positive, either it is negative, or it is 0. That means if the discriminant is 0, right, the first one, if b square minus 4ac is equal to, let me say, is less than 0. Less than 0, that means negative number. At that time, if this is less than 0, then no real roots exists, right? No real roots will exist. If b square minus 4ac is less than 0, then no real roots exist. If b square minus 4ac is equals to 0, then real and equal roots exist, right? If it is equal to 0, then real and equal roots exist, and if b square minus 4ac is greater than 0, then real and distinct roots exist, right? So there are three cases, that if it is less than 0, if it is equal to 0, and if it is greater than 0. If b square minus 4ac is less than 0, then no real roots exist. If it is equal to 0, then real and equal exist, and if it is greater than 0, then real and distinct roots exist. Let us understand this in the form of a tree. That means discriminant d equals to b square minus 4ac we are having mainly two cases, that if it is less than 0 and if it is greater than or equal to 0, right? When we are dealing with the inequalities, we are having mainly two cases, that if it is less than or equal to 0 or less than 0, and greater than or equal to 0 or greater than 0. So if it is less than 0, what it is less than 0? That means b square minus 4ac is less than 0, then no real roots, right? This will give me no real roots. Again, if it is greater than or equal to 0, there will be having two more cases, that whether it is equal to 0, whether it is greater than 0. If it is equal to 0, then real and equal roots. If it is greater than 0, then we shall have real and distinct roots, right? So you need to understand this tree, that the value of discriminant, that is b square minus 4ac, right? b square minus 4ac, if it is less than 0, then no real roots. If it is greater than or equals to 0, again if it is equal to 0, then it is real and equal, and if it is greater than 0, then it will be real and distinct, right? So if you understand this tree very well, then there is no need of memorizing this by heart, right? You can easily come to know that whether the roots here for the given equation will be real and equal, real and distinct, or no real roots for the given equation exist, right? So friends, I think you might write down this in your book whenever you are having this video, right? Okay, so we have solved I think two examples. Let us see the third one. I am having an equation again, x square plus x minus 306 equal to 0. See friends, this equation is again taken from the very first topic, the formation of the quadratic equation, right? Again, let us see, let us verify that we are getting the equations, we are getting the roots perfectly or not. So here a equals to 1, b equals to 1 and c equals to minus 306. Therefore b square minus 4ac, right? B square, that is 1 square minus 4 into 1 into minus 306, that is 1 minus minus plus, and that is 1224, that is 1225, which is greater than 0. Now you can come to know that if this is greater than 0, then what does this indicate? That the roots of this equation will be real and distinct roots. Good. Now the roots of the equation are x equals to minus b plus or minus root b square minus 4ac upon 2a, that is minus 1 plus or minus root 1225 upon 2 into 1, that is 2, that is minus 1 plus or minus 35 upon 2. Hence that becomes minus 1 plus 35 by 2 comma minus 1 minus 35 by 2. Hence this leads me to x equals to 34 by 2 and minus 36 by 2. Hence x is equals to 17 and minus 18, right? So the solution of the given equation is 17 and minus 18. Is it clear? Now moving on to the fourth question of the same method, that gives me an equation here is 2x square minus 7x plus 3 is equal to 0, right? So we shall find out some method. We shall use this quadratic formula here. That means here a equals to 2, b equals to minus 7 and c equals to 3. Therefore b square minus 4ac, that is minus 7 square minus 4 into 2 into 3, minus 7 square, that is 49, minus 4 into 2 8, 8 into 3 24, which is 25 greater than 0. So we got a value 25 which is greater than 0. So again, what you can say about the roots? The roots here will be real and distinct. Now the roots of the equation are x equals to minus b plus or minus root b square minus 4ac upon 2a, right? Therefore, what you can say? Therefore, x equals to minus b, that is minus of minus 7 plus or minus root 25 upon 2a, that is 2 into 2, which gives me 7 plus or minus 5 by 4. Hence, you can say that x is equals to 7 plus 5 by 4 and 7 minus 5 by 4. Therefore, x is equals to 12. 7 plus 5, 12. 12 by 4, 3. And 7 minus 5 is 2. And 2 by 4, that is 1 by 2. Is it clear? So we got the solution x equals to 3, 1 by 2, or the roots of the given equations are 3 and 1 by 2. Is it clear, friends? So similarly, again, let us take one more example. 5, that is 2x square plus x minus 4 equal to 0. So again, what we shall do here? A equals to 2, b equals to 1 and c equals to minus 4. Therefore, b square minus 4ac, that is 1 square minus 4 into 2 into minus 4, that is 1 minus 4 into 4, 16 into 2, 32. But again we are having minus minus plus, that is 32 and that is 33, which is greater than 0. Therefore, the roots of the equation are x equals to minus b plus or minus root b square minus 4ac upon 2a, right? Let us put down the values here. That is minus 1 plus or minus root 33 by 2 into 2. Therefore, x equals to minus 1 plus or minus root 33 by 4. These are the roots. You cannot simplify further because root 33 is not possible here, right? Because that is an irrational number. So you cannot simplify root 33 and hence there is no further simplification possible, right? Now see, one more example here is x square plus x plus 4 equal to 0. This is an interesting one, right? Sometimes the paper setter might trick you by giving you this kind of example, and if it is said that find out the roots of this equation, then what you will do here? A equals to 2, b equals to 1 and c is equal to 4. Therefore, b square minus 4ac, that is 1 square minus 4 into 2 into 4, that is 1 minus 32, which is minus 31 less than 0. Note that, friends, we got the value of b square minus 4ac as minus 31, which is a negative value. which is a negative real number, right? That means this is less than 0, and we have studied in the nature that if b square minus 4ac is less than 0, then what are the nature of the roots? No real roots exist, right? So here b square minus 4ac less than 0, so no real roots exist, right? And hence you get no solution of this equations. That means no real roots exist for this given equation. So that was the example I was talking about, that what to do when you are having no real roots exist.